Hi again. This is Mr. Ford, and we got the last unit for this induction week of measures of dispersion. So this is just something we've built on. So I'm going to show you a bit further as well what you'll be looking at in terms of something called standard deviation. But first off, we're just going to look at basic measure of dispersion. What I mean by dispersion is the idea of you've got range, the variety of results. So how the biggest versus the smallest. Another way to think about it is whether the results are consistent. If you've got results that are really consistent, then you've got a very tight group, so the dispersion is very limited. There's two types of dispersion. We're talking about the range, which is not the greatest, which is when we get the highest value minus the lowest. Okay, so it's the maximum distance between the data values. And then you've got the interquartile range. Now, the interquartile range is just the difference between the quarters, the quartiles. So the difference between the lower quarter, so the 25% grade or mark, and the 75% piece of data. Of course, you need quantitative data for this to be able to work. Okay, there's a little piece here. In year 13 and throughout year 12, towards the end of the year, you'll be looking at standard deviation. So because of that, standard deviation is going to be the other thing you'll be looking at today. So let's look at two different ones. The first one is looking at calculating these range or interquartile range and comparing. And the next one will be actually looking at commenting. So this first one here, an investigation was carried out into the number of zooplankton at two different sites. We had some in high salinity water and some in low salinity water. So what we want to do, and what it's going to ask us to do, is we're going to compare the dispersion, the spread of these results. So the first one has us looking at range. So let's look at the range. So the highest value here for this one is 102, and the lowest value would be, and if we look at this, the lowest value is 68. So the range for high salinity water, okay, will be, we do RH, 102 minus 68, which is going to be 34. And the range for the low salinity water, well, we have to look here. So we have the highest value being 67, and the lowest value being 45. So our range would be our highest minus our smallest, which would be 67 minus 45. And that would give us a range of 22. So if we're going to look at the dispersion, how spread these results are, with the range only, we can notice the fact that the high salinity water has a higher range. Therefore, it is less consistent. Or you could also say it is more varied. Okay, that's it. It has a higher range because it's got a larger range here, which means it's less consistent or it's more varied. Now let's look at the next one. Now this is something that's done in a number of different subjects. I know that psychology, as well as those in comparison with science, but psychology and geography will be doing these as well. So interquartile range. Calculate the interquartile range from both sides and then comment on them. And then it's just saying, is there a difference between the range and IQR? And we'll have a look. So the interquartile range, we need to find the quarters. So you'll notice that there are 1, 2, 3, 4, 5, 6, 7 results. So if there's 7 results, what we can do, there's two ways we can do it. We could just order them. So we have our lowest value of 68, then we have 72, 83, 85, 91, 92, and 102. And I'll do the same for this one over here while I'm at it. Okay, so what we can do here is we can do what we used to do for median. You can cross off as you go. So we can cross off this one and this one, this one and this one, this one and this one. So this is the middle result. Okay, so that is our median. Now, that means this is going to be our median as well because they've got the same number of results. If we look halfway through, this one will be our lower quartile because it's halfway between these. And this one will be our upper quartile. You can see that because if I cross off here, this is the one remaining in the middle on the upper side, and on the lower side, we've got that one there. There is another way to do it. So some formula that you were taught is if you wanted to find the location of the median, this is the middle result, what you can do is you can do the number of results plus 1 divided by 2. So in here we have 7 results. So it would be 7 plus 1 divided by 2. So it would be the fourth highest result, which if you notice, 1, 2, 3, 4. The lower quartile is the same, except we're going to divide it by 4. And the upper quartile is always in the same position as 3 times the lower quartile. That's the best way to do it. So let's take those quartiles and actually find our interquartile range. So again, there's two methods here. There's one which is the crossing off technique. You can find the middle one, and then on either side you can cross them off until you find the middle point there, or you can find out the location. So you can do the number of results plus 1, then divide it by 4 for the lower quartile, and for the upper quartile, it's 3 times it. Because 3 times 1/4 is 3/4. Now, let's do our interquartile range for this first one. Now, interquartile range B, so we have 92 is our upper quartile, minus 72, which is 22. Now, this is for my high salinity water. For my low salinity water, I've got, so we can look across, so this is our upper quartile, this is our lower quartile. We have 61 minus 49, which is going to be 11. 11, I can't even do it there. Let's fix that very quickly. 12. Okay. Now, what you may notice is that you still have the same sort of consistency in terms of the high salinity water is still more consistent, more varied. It is less consistent because it has a higher interquartile range. It is more varied than the low salinity water, just like our first one. The biggest thing that's really good about our interquartile range is it removes any extreme values that are really high or really low on our range. So just to repeat, we have the same comment here that we could say for the one above, but it's really good. The reason we use an interquartile range instead of a range is it removes or disregards extreme values. If I had one value that was really high or really low. Now there's some practice here for you to do. Give them a go. Now the other part of the video is we've got this here, this question. So a psychologist wants to investigate how expectations influence our perceptions of food. So they basically give, you can have a read of this, they give one group a packet of crisps that have premium range on it, and they give another group the same packet of crisps, but they say it's budget range and it's in a plain packet instead of bright and colourful. They're then asked it to taste it and then give it a rating from 1 to 20. And here is the results. Outline 2 conclusions that can be made about this experiment from the calculation of the range. So it tells you what to do, but really, whenever you're looking to discuss or make decisions about data, you should always do one of two things. First, you should always talk about the actual average. What is the average of the results? If the average of the results is higher than the other result, you would say the on average one is greater than the other. The other point you can always make, so whenever you're commenting on data, you always talk about the average, which if you remember, we're talking about your mean, median, or mode, and you talk about the dispersion or spread. Okay, so let's have a look. First off, let's calculate our range. So for this one, our lowest result's 8 and our highest result's 20. So we have a range of 12. And this one, our lowest result is 2, our highest result is 18. So we have a range of 16. So if we're going to outline 2 conclusions from this data. Okay, so the first thing I could say is the fact that the range actually varies quite a lot. If we got a rating of 0 to 20, and they're the same crisp, the range is varying quite a lot for tastiness. Okay, so the range is varying quite a lot for tastiness of both the premium and the budget brands. Because it's quite a high range. The other thing you could say is the first one, the range varies greatly about taste of crisps. Okay, and the other thing you could say is you would talk about the comparison between them. So you would turn around and say, okay, so actually it's saying here that the budget branding shows people. So in this case, we're using context from the question, shows people have a wide range of opinions for taste of crisps, for taste of the budget crisps. Okay. Now, of course, you could turn around and say, you can include a little bit of the fact that this means that there's a very low score and a very high score within this range. But that's it. You make conclusions about the data. You've talked about it being a very large range and that there is a difference between the two. Thank you. I'll see you soon for standard deviation. Make sure you try the questions here.